Hello everyone, this is Himashri from CSE. So today I'm going to explain the concept of queue using arrays, which is a very important topic in data structures and will be learned in the basics of data structures. So what is a queue? A queue is a linear data structure that follows the FIFO principle, which means first in, first out. In simple words, the element that is inserted first will be removed first. So we can relate this to real life examples like when people um, stand in a line at a ticket counter, the person who comes first gets the ticket first. So in a queue, insertion happens at the rear variable and the deletion happens at the front variable. Whereas in stacks, we have seen that the variable we use for both insertion and deletion functions is top. So overall, queues help in maintaining order and fairness in processing. Basic operations. So there are few basic operations in a queue. So enqueue is used to insert an element at the rear, and dequeue is used to remove an element from the front, and pkey is used to view the front element without removing it. And we also have some functions like is empty and is full to check the status of queue. And yeah, queue representation. So a queue can be implemented using arrays. To manage the queue, we use two pointers called front and rear. Initially, both front and rear are set to -1, which indicates that the queue is empty. As in the beginning, queue is empty. So as elements are inserted and deleted, these pointers move accordingly. So let me try to visualize the queue with a simple diagram here. So let's understand queue as this both lines. So here is the enqueue function, which means simply insertion. And let's understand this as deletion. So an element is entered into the queue with this in this side, and the deletion happens from this side. So here the variable rear is used, and here the variable front is used. Okay, so now that we have understood how a queue is represented, let's understand the operations in them. So in the enqueue operation, we insert an element into the queue. First, we check whether the queue is full. If the queue is empty, we set front to 0, and then we increment the rear pointer and insert the new element at that position. And dequeue operation. In the dequeue operation, we remove an element from the queue. First, we check if the queue is empty, so that we'll show the error. And if not, we remove the element at the front and then increment the front pointer. If front becomes greater than rear, the queue is reset, meaning it becomes empty again. Stacks versus queue. Now that you have understood the both enqueue and dequeue operations, you must have understood that the functionality of both queues and stacks is same, but the way we are achieving it is different as we are using different variables and different names for the functions. So a stack follows LIFO, which means last in and first out. So the last inserted element is removed first. On the other hand, a queue follows FIFO, where the first inserted element is removed first. So in a stack, both insertion and deletion happens at one end, called the top. But in queue, insertion happens at rear and deletion happens at front. So overall, stack is like a stack of plates, while queue is like as we have said earlier, a queue line near any movie or ticket counter. So now we have came to applications. So queues are widely used in many real world applications. For example, in CPU scheduling, printer queue, call center systems, and Okay. So queues are most important because they help in maintaining the correct order of execution. They ensure efficient processing and are widely used in operating systems. And because of the structured approach, queues are essential in many computing applications and they're widely used. So I hope you understood this concept of queues using arrays. And the program is very similar to the stacks one, just replace the enqueue function with the top variable rare variable, and in dequeue function replace the top variable with the front variable, and the program is almost the same. So I hope you understood the concept. Thank you.